The amount of information out there is more than overwhelming. It's frightening. Search tools use only the most common meaning for each word, which is why your searches too often are exercises in frustration. It's even worse for organizations that get millions of documents but only want the important ones. This video presents a better way to find what you need, the relationship analysis approach to natural language understanding. There are different ways to analyze language. We'll start with just syntax. Then look at the commercial semantics approaches. And then the relationship analysis approach, which allows you to understand natural language in context with an unrestricted vocabulary for any language, such as English, French, Russian, Arabic. And we'll see some applications that can be done with relationship analysis. The syntactic approach is just about the sentence structure, not about its meaning. The focus is on verbs, nouns, etc. Here are a couple of examples that the European Union has used to decide if a language system is good or not. The bandage was wound around the wound, and I had to subject the subject to a series of tests. These are easy. If a word is preceded by a helper verb, it's a verb. If it's preceded by an adjective, it's a noun. Easy. Analyzing for meaning is very hard. And because meaning isn't involved, only the most common meaning is always selected. That's why so many translation programs are so awful. The best language analysis systems focus on semantics. There are two general approaches used in commercial products: example-based statistics and latent semantic indexing. Example-based statistical systems are developed by manually collecting word group examples of meaning. When the system is done, new text is compared with the stored examples and statistically analyzed. Needless to say, you need lots of examples. Eventually this works, but it's such a crude way to design software. It's also the way nearly all commercial language understanding and translation software is designed. Latent semantic indexing systems focus on special topics. Again, example documents of the area of concern are read into the system to train it. When it's trained enough, new text is statistically checked to see how closely it relates to the examples. This example training is a common form of artificial intelligence systems for such varied applications as X-ray analysis and aircraft identification. Not only do you need lots of examples, but the system can only analyze new stuff in that domain. If you want to analyze a different topic, you have to write and train a new system. Here's the problem with semantics. Let's say there are two ladies talking, and one says, "I like squash." The other lady should be confused about the intended meaning. But if the sentence was, "I like to play squash," the ambiguity has been resolved. Because the listener knows that one meaning of play is games, and one meaning of games is squash. Language specialists say this is because her world knowledge lets her understand what's meant. Relationship analysis, on the other hand, suggests there's a natural intelligence within language. I suggest that the speaker, in constructing a sensible sentence, has automatically and invisibly put the meaning of each word within her sentence. So game is implied within the sentence. And the listener, when hearing the sentence, takes those meanings out. Notice there's no listener world knowledge in this. Here's an example. When you see this sentence, you know what the words mean, irrespective of how you do it. What about this sentence? What do these words mean? Actually, they're the same sentence, with T's replaced by G's, and so forth. But language is more complicated than that. In "that sun is hot," sun can be any of these three nouns, or either of these verbs. And hot, which is an adjective, can have any of these 18 meanings. So we have 5 possible meanings for sun, linked to 18 possible meanings for hot. which comes to 90 possible sentences, only one of which is the right one. Analyzing with relationship analysis, the best meaning of sun is matched with the best meaning for hot. Take these 3 sentences. Using relationship analysis, you understand the natural language in context, with an unrestricted vocabulary, no matter what the language. And there are various applications using this relationship analysis engine, including text analysis, questions and answers, document summaries, and high-quality machine translation. We'll see how all of these can work. If a typical commercial language analysis system sees the sentence, "My candidate is running," this will be the result. Not exactly what you want. Using relationship analysis, you get what you want. Okay, let's look at the system. The most direct way to demonstrate that the correct meaning of a word was selected is to translate it into other languages, because those languages will have different words for each meaning. I've developed a software demo to show this, with source languages being English, French, or Arabic, and target languages being English, French, and German. The source sentence will be translated into the target language. In this case, we have the English sentence, "My candidate is running," and we click on Translate from English. And as you can see in the French translation, the meaning for running is something to do with elections. Just what we hoped for. Relationship analysis scanned all the meanings of all the words and picked the ones it felt were the most closely related. Now let's try "My refrigerator is running" and "My nose is running." Again, looking at the French translation, we see that for refrigerator, the meaning for running is operating, and for nose, the meaning is dripping. Let's try "My candidate is running a temperature." And the translation shows something to do with having a fever. Again, all the meanings were analyzed, and the most closely related were selected. That's relationship analysis. Here's an easy one. The hot dog is ready to eat, but the system has to recognize hot dog as a 2-word phrase. And as you can see in the German translation, it did that and chose Frankfurter. What will happen if we change one word and change that meaning? Again, the German translation shows an overheated canine rather than a Frankfurter because it related the word bark with an animal. But that left hot hanging around with its 18 possible meanings, all of which have to be analyzed. Relationship analysis decided that heated had the closest relationship, so that meaning was chosen for hot. Let's try some Arabic source sentences. As you may know, Arabic goes from right to left, and relationship analysis can read from right to left when it has to, and can read Arabic script when it has to. I've also transliterated these sentences to show the English meanings in the same physical order as the Arabic words. As you can see, these 2 sentences are identical, except the first one has the subject, while the second one has the food. But when translated, the first word in the first sentence is dealt with, while it translates to ate in the second sentence. And sure enough, the professor dealt with the subject. And the professor ate the food. Here's an example of word nuances. The rooster crows and the professor yells. Again, notice the change in the first word depending on if it's a rooster or a person. And yes, the rooster crows and the professor yells. Now we'll look at an example of adding information to a sentence to change the meaning of a word. Notice that these 2 sentences are identical, except that "my wife's" has been added to the second one. That changes the word before it from Jeddah to grandmother. Sure enough, when relationship analysis is run, the first sentence is Jeddah, and the second sentence is "my wife's grandmother." We didn't focus on the French and German translations, but they show another powerful feature of relationship analysis. In French and German, when you're visiting a place, You say it differently than if you're visiting a person. Commercial translation systems can handle that difference, which is one reason their results often sound so silly. Relationship analysis handles it. In other machine translation approaches, a syntactic and semantic analysis is done on the source language, and the words are arranged in the target language. This technique must be done for each source language with their various target languages. For 4 source languages, you need 4 times 3 translation programs. Relationship analysis started in the same way. But then I considered a main part of Noam Chomsky's theory of universal grammar, where syntax is language-specific and semantics is the same for all languages. If that's true, a single semantics routine would work with any language. So I separated the syntax analyzer from the semantics part and designed a bridge program as a language-independent semantic interpreter. So now, if we're translating from Russian to English, the Russian syntax is analyzed and goes through the semantic interpreter. Then the words are arranged in English. But now, any language will go through the same interpreter to be arranged in whatever order is needed. So for N languages, you need 2 N translation systems, which has a big impact on the development efforts. For the European Union, you would only need 48 programs instead of 552 to translate everything for the languages in all the countries. There are 2 main parts to the relationship analysis process. The relationship analysis engine does the complex analyses to identify the most related meanings of all the words in a sentence. Ray uses a specially constructed database called the Language Independent Semantic Taxonomy. The list contains all the words and phrases in a special coded format. I've developed a few prototype applications to demonstrate Ray, and we'll look at how they work. The list index with all the words is populated by X-Ray. Text is analyzed by SearchRay. Document summaries are done by SummaRay. And the kind of high-quality machine translation you've already seen is done by Translate. For text analysis, the problem is not the text, it's the context. When we say, "we'll meet at the bank," are we asking for a loan? Are we looking for where the fishing is good? Are we looking for a bank of spotlights? Relationship analysis identifies the context. Here's a text analysis situation. You have possible terrorist computers with dozens of folders in them with names like recipes, sports, and colleges. Each folder has subfolders and hundreds of documents. You suspect that somewhere in one of those documents is information on a terrorist attack. How do you find it? The way you find it is by using SearchRay. SearchRay scans computers for user topics of interest, harvests the topic information for user analysis, in context, in any language supported by the system. We start by creating a topic, which is terrorism in this case. Because of the various meanings of many words, this topic must be clarified. I chose the first 5 words that came to mind about terrorism. They're not the best, but that's what I chose. Then I hit the Create button. Now we choose terrorism as our topic and the database to search. Then hit the Search button. Relationship analysis goes through the files one at a time to find passages that refer to terrorism. When it's finished, it shows the number of files it searched. Then you click to display the current report. Here's the report in order by likelihood with identifying information. One thing you may notice is that none of the words in any of the found passages has any of the words we use to describe terrorism. That's because relationship analysis uses those described words to identify list entries containing hundreds or thousands of words to check. Okay, let's say we have trickier terrorists with all their messages in Arabic. No problem. Just choose Arabic as the language and hit search. No other changes or information are required. The same process is done with each file inspected and the total shown at the end. And when we click to display this report, you'll see passages in Arabic that refer to terrorism. Relationship analysis is language independent. Here's another text analysis situation. Bloomberg constantly gets news feeds on topics of all kinds. Their clients are interested in the latest information, but only on specific topics. How can they get what they need? And again, our solution is SearchRay. Each client has topics created for them. As the news feeds are read, those topics are routed to databases for each client. A bit more complicated than the first example, but the process is basically the same. Here's a different situation: questions and answers. Military intelligence and operations personnel need an automated way to collect information from raw, unstructured data sources for tell me about questions. And the way we can do this is by using X-ray and SearchRay. In this case, special categories may need to be created for special customers, something X-ray would do. The tell me about question is a form of topic with answers for it coming from one of the databases or the web. SearchRay would find those answers and create reports. Here's another situation: document summaries. You continuously receive documents but don't have the personnel or time to read them. How can you find out which documents should be closely read? And the way we do this is with SumArray. In this application of relationship analysis, SumArray analyzes the text, produces a summary of the documents, including the most significant words and phrases in the text, the most significant concepts in the text, and the most concept-significant sentences from the document. It produces a coded file of the text suitable for further software processing, and users have as much or as little information about the document as they like. We've already seen the kind of high-quality machine translation relationship analysis can do, but we can extend that beyond text to voice. Here we have a smartphone with an any language app. The user can point the phone towards a French speaker, and the app will collect the phonemes for processing by Translate, which sends the translation to the user's earpiece. If the user then travels to Russia, all he or she has to do is replace the French language dictionary with a Russian language dictionary, which also includes the syntax, and relationship analysis would do the translation from Russian. So, in summary, relationship analysis analyzes text in context with an unrestricted vocabulary for any language, and has flexible applications such as text analysis, questions and answers, document summaries, and high-quality machine translation. And no examples or training are needed. The prototype applications you've seen are just that, prototypes, with just enough syntax and words to show their capabilities. The semantic engine is complete for all languages, but may need to be adjusted as further testing is done. To make these applications commercial products, complete syntax and words for each language must be added. These are available, but special formatting must be done as a development effort for relationship analysis. Two identified research goals to broaden relationship analysis are the following: to change the list structure from two-dimensional to three-dimensional, which would help in some relationships and would speed up the processing. And the second one is to add image and sound features to the language analysis to make it a major component of future artificial intelligence systems. By the way, the original Microsoft speech analysis system was given the phrase, "how to recognize speech," and it came back with, "how to wreck a nice beach." The Microsoft Speech Analysis Project became the Wreck a Nice Beach Project. Well, that's the why and how for relationship analysis. You're welcome to contact me with any questions, comments, or advice. I try to be a good communicator.